Permutations and combinations. Permutations and combinations. First, we want to define permutation. The different arrangements can be made out of a given number of things by taking some or all at a time are called a permutation, denoted by NPR. It is an arrangement. For example, in a school, the teacher is arranging the students. That is a strictly arrangement or rigid arrangement. The teacher has the right to arrange the students in a classroom. No other person can interfere them. Or if a photographer is taking the photos, then he is the right person to arrange the students or persons. So that such an arrangement is called a permutation, denoted by NPR. N means maximum number of persons. R is some number of persons. So it is an arrangement of things taking some or all at a time. Its equation for finding is n factorial by n minus r factorial. The term factorial means, n factorial means 1 into 2 into 3 into etc. up to n. For number 5 factorial is multiply the product 1 into 2 into 3 into 4 into 5 up to that 5. That equals 120. And NPN equals n factorial. If we arrange them fully, it means NPN means n factorial. Next, permutation of repeated objects. Repeated objects. The number of permutations of n objects taken all at a time equals n factorial by p factorial into q factorial, where p is the observations all of one kind and q is of second kind. We have the extension formula also, n factorial by p factorial, q factorial, etc. So permutation of repeated object equals n factorial by p factorial into q factorial. The number of permutations of n objects taken all at a time when p of them are alike of first kind and q of them are alike of second kind. And if we have extended it, we get n factorial by p factorial into q factorial into r factorial, etc. Now circular permutation. The number of ways in which n different objects can be arranged at a round table equals n minus 1 factorial. The number of ways in which n different objects can be arranged at a round table, that is circular permutation, equals n minus 1 factorial. When no distinction is made between clockwise and anti-clockwise arrangements, then number of ways equals n minus 1 factorial by 2. The number of ways in which n different objects can be arranged at a round table equals n minus 1 factorial, and when no distinction is made between clockwise and anti-clockwise arrangements, then the number of ways equals n minus 1 factorial by 2. Now I can do some problems. Evaluate 8 factorial. Evaluate 8 factorial. 8 factorial means 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. We get it as 40,320. Second one, 4 factorial minus 3 factorial. 4 factorial means 1 into 2 into 3 into 4 minus 1 into 2 into 3. We get 24 minus 6 equals 18. Next one, is 3 factorial plus 4 factorial equals 7 factorial. We have to check whether 3 factorial plus 4 factorial equals 7 factorial. So find them separately. 3 factorial plus 4 factorial equals 1 into 2 into 3 plus 1 into 2 into 3 into 4. 6 plus 24. So the answer is 30. But 7 factorial equals 1 into 2 into 3 into 4 into 5 into 6 into 7. That is 5040. These two are not equal. So 3 factorial plus 4 factorial not equal 7 factorial. Next one. Compute 8 factorial by 6 factorial into 2 factorial. Compute 8 factorial by 6 factorial into 2 factorial. 8 factorial we can write 6 factorial into 7 into 8 because 6 factorial contains 1 into 2 into 3 into 4 into 5 into 6. Here also 6 factorial into 2 factorial means 1 into 2. We can cancel 6 factorial. 2 and 8 we get 28. Next one, if 1 by 6 factorial plus 1 by 7 factorial equals x by 8 factorial. We want to find the value of x. 1 by 6 factorial plus 1 by 7 factorial equals x by 8 factorial. Find x. We know 1 by 6 factorial plus 7 factorial can be written as 6 factorial into 7. X by 8 factorial can be written as 6 factorial into 7 into 8. From which we can find the value of x. We can cut the common number 6 factorial. So we get 1 plus 1 by 7 equals x by 56. So that take the LCM. 8 by 7 equals x by 56. Cross multiplying. 8 into 56 equals 7x. So that x equals 8 into 56 by 7. So the value of x is 64. Next one, evaluate n factorial by n minus r factorial when n equals 6 and r equals 2. Evaluate n factorial by n minus r factorial when n equals 6 and r equals 2. Substituting the value here. 6 factorial by 6 minus 2 factorial, that is 6 factorial by 4 factorial. Simplifying we get 4 factorial into 5 into 6 by 4 factorial. So the answer is 30. Second one, n equals 9 and r equals 5. So the answer is 9 factorial by 9 minus 5 factorial. 9 factorial by 4 factorial. The answer is 4 factorial into 5 into 6 into 7 into 8 into 9 divided by 4 factorial. The answer is 30 into 7, 210 to 72. So 21 into 72. 15120. 15,120. Next one, find n if n minus 1 P3 is to n P4 equals 1 is to 9. Find n if n minus 1 P3 is to n P4 equals 1 is to 9. N minus 1 P3 means, for easy method, we can start from n minus 1 and going 3 previous numbers, n minus 1, n minus 2, n minus 3. For example, 4 P3 can be easily written as 4 into, starting from 4 and going 3 numbers back, 4 into 3 into 2. Like the same way, n minus 1 P3 starting from n1 and go back 3 terms, n minus 1, n minus 2, n minus 3. Ratio means division. n P4 we can written as starting from n and going back 4 numbers, n into n minus 1, n minus 2, n minus 3 is given as 1 by 9. So we can cancel n minus 1, n minus 2, n minus 3, so that we get n equals 9, cross multiplying, n equals 9. Next one, how many words? With or without meaning? With or without meaning? Can be formed using all the letters of the word equation. Using each letter exactly once. How many words with or without meanings can be formed using all the letters of the word equation, using each letter exactly once? So, total letters are 1, 2, 3, 4, 5, 6, 7, 8. So, required number of different words equals 8p8. We are taking all letters. So, all the arrangements are doing here 8p8. That means in 8 factorial, since npn is n factorial. So, 1 into 2 into 3 up to 8. So, the answer is 40320.